So now I'm set up to add my spring constraint. Go back to shaded mode. I've still got my low LOD object selected, and I'll add soft rigid bodies, create spring constraint. And it too is created very small at the object's center of mass. So let me hide these high LOD objects again. Go back into wireframe. It's selected, but I'm not seeing it terribly well, but there it is. It's right at the center of mass. So I'll grab the move tool and pull that directly up. Okay, now I can see what I'm doing. So I just want to move that up near the barrier, up where that center of mass is going to end up when it gets pulled. So I'll do that in my ortho view. Once again, tap the space bar. In this front view, I'll just move the center of mass icon. And once again, you can see that there's a line connecting the spring constraint to the object's center of mass. So going back to my perspective view, I'm ready to test this, rewind and press play. Well, my spring isn't strong enough to overcome the force of gravity. Remember that the gravity magnitude is way up at 980. The spring stiffness over here is the magnitude of the constraint. So let me change this to a value of, let's say, 50. And play my simulation. And it does work, but it's not throwing the projectile far enough. This is supposed to be a range weapon, so it's not going terribly far. So let me rewind and increase this up to a value of maybe 500, and that should get it shooting off pretty far. And it did. It seemed like it sent the ball off into space. And that's good enough as far as that's concerned. But as you see in my example, and in yours, you'll probably see something similar, that the arm is actually going through the barrier at some point. Let's go ahead and save this file, save scene as, and I'll call it catapult01.ma. There are two windows where you can adjust the solver settings for this simulation, and they're both found in the Dynamics menu set under Solvers. The first one I just want to show you in passing is the Edit Oversampling window. It says Edit Oversampling or Cache Settings. And it opens the attribute editor, and you can see an oversampling attribute here. And what this does is it calculates each frame of the simulation more than once. In fact, the scene that I've given you already has it set up to 3, and that's the pretty much optimal setting. But if you want to speed up your simulation, you can reduce it back down to the default of 1. But I recommend that it usually be set to 2 or even 3. Any higher than that doesn't seem to help it. So that's the oversampling window. The other one I want to show you is in Solver's Rigid Body Solver Attributes. And here's where we can correct this error here. Take a look at these two attributes at the top, step size and collision tolerance. Those are the two most important. Step size is the time base. Lower values are more accurate. So the reason that this error is occurring is because of very fast moving objects, and the time base isn't keeping up with the action. So if I reduce the step size, that should correct that issue. So it's at a default of 0.03. Let me try a value of 0.01 instead. And I'll rewind and play back. And now it's staying put, and I'm not getting that issue anymore. Go back to my Solver's Rigid Body Solver attributes. And I just want to mention also the collision tolerance here, and that's the spatial accuracy. That value is the distance between two surfaces where the solver will consider them to be touching. So in other words, if you have two surfaces that are 0.03 centimeters away from each other, then the solver will think that they're not touching. But if they're 0.02 centimeters away from each other, the solver will think that they are touching. Practically speaking, once again, lower numbers are more accurate and higher numbers are less accurate. Higher numbers will calculate faster as well. So you can play around with this if you want to speed up your simulation, but remember the default here of 0.02, and you may need to bring it back down there after you've played around a little bit.